Okay, so today I want to show you how to use this Snap-on Bluepoint EEFE310 Amp Tool. So this is used in replacement of a meter to check current draw on a system. So I have the cover off on the fuse panel underneath the hood, so I've taken that off, and I've identified the circuits on the fuse panel. So I'm going to take and hook up this adapter so we can measure the current right on this display as the circuit is operating. So we're going to take the hazard lamp fuse, or the hazard circuit fuse, and it's a 10 amp fuse. It's located right here on the fuse panel. It says hazard, and I'm going to take the fuse and remove the fuse, and then I'm going to come over to this adapter here, and I'm going to take the fuse and I'm going to put it into the adapter. There actually is a slot in here to put the fuse in. So I'll plug that in, push that all the way down, make sure it's seated. Okay, so that's where the fuse goes in. And then we're going to take these terminals and we're going to put them in replace of the fuse. So we'll put this, get this untangled here, and we're going to plug this in right down where the original fuse went, and it fits right down in the slot. So I'll turn this over here so you can see it. Now what we want to do is we want to make the circuit operate. So I'm going to go and turn the hazard lamps on. And you can see the hazard lamps are actually working, and I'll bring that over here, I'll pan over so you can see them. You see them flashing, okay? And if I come back and take a look at the current, it shows me how much amperage is being done in the circuit. Now, you can see it's going up and down, it's flashing up and down. But what we can do is we can actually hit the hold button. If we hit it at the right time, that's going to show us the low side. There we go. So it's 7.6 amps, and you can see I got it on hold. This is a handy little tool to check a circuit to see if a circuit's functioning correctly. Now you can take this amount of amperage and you can plug it into Ohm's law and find out exactly how much voltage should be in the circuit, or we could do it vice versa. We could take the voltage that we have, which is 12 volts at the battery, and we can figure the resistance of the circuit, which is all the bulbs, and are all wired in parallel, and then we can come back and see if this amperage is correct. Now, one of the things that you need to look at when you're looking at amperage, and I'm going to hook the meter up in another video and show you that, but one of the things you want to look at is when the circuit turns on, you want to see if the amperage starts to go up or not. So the next step, so this is a continuation of the video we started with this Bluepoint amperage tool. So our next step is going to be, we're going to hook into the headlight circuit. So the same thing, we're going to come over to here and we're going to look and see what fuses operate the headlights. So this is the one for the right side, this is the one for the left side. So if I take this fuse out right down here, and if I take the fuse and if I put it into the tool, like so, and I push it all the way down in, and then I take the tool and I slide it down into the slot for the headlights. I make the connection on the connectors there. And now if I go and turn the headlights on, and you can see it shows no amperage. That's because this is for the high beams. So I'm going to take the high beams and turn the high beams on. And now we can see that the high beams are drawing 4.5.6 amps. Now if we had a shorted wire, a bad conductor, a shorted headlamp bulb, etc., something causing the current to go up, this amperage would start to climb and climb and climb, and eventually when it reaches 10 amps, which is what the fuse is rated for, it would pop the fuse.